Right? So good evening. Next, our topic is today. Topic is okay. Yes, presentation. Yes, entire screen presenting. Okay. Record already started. Okay, right. So 3D geometry plane today. 3D geometry. Okay. So plane. Right. Okay. Plane. Right. Now see plane equation under different conditions. Number one condition is normal form. So this is normal form of equation of line, equation of plane. Okay, normal form. Okay, in this form, see what are given, right? So what are given to find the equation of plane, right? Okay, here normal vector is given. Normal vector generally denoted by n bar. Normal vector and perpendicular distance from horizon to plane, okay, are given. See, under these two things, normal vector, this is, and perpendicular distance from horizon to plane. When these two things are given, okay, so how to find the equation of plane? Okay, right. See, this is the plane. We can see the example of this board is also a plane. Okay, this screen is also a plane. Okay, this one wall is also a plane. So that is a plane. Okay, right. So smooth surface. So that is okay. Plane surface is called a plane, right? So see, this is a plane. Okay, right. So right, this is a plane. Now see, in the space, this is the space, XYZ axis. This is the space. Okay, this horizon, right? See, what are given here? Normal vector. What is meant by normal vector? A vector perpendicular to the plane is normal vector. Normal vector means a vector perpendicular to plane. Okay, this is the plane. So perpendicular to this. So if you take any line on this plane, so this angle is perpendicular. This is n bar. Okay, right. Okay, so normal vector, not only here also, anywhere we can take, here also we can take, no problem. So okay, see here also we can take normal vector. Normal vector is perpendicular vector to the plane. that a vector perpendicular to plane is normal vector. So this we denote by n bar. N bar is a normal vector, right? So one more thing is given, perpendicular distance from horizon to plane. Perpendicular distance, this is perpendicular distance from horizon to plane. This is the perpendicular distance. Okay, perpendicular distance from horizon to plane. Okay, see, this line is not going inside the plane, it is, okay, perpendicular distance means, so this is horizon, this is the perpendicular distance. Okay, right. వాళ్ళకి మరి అర్థం అవుతుందో లేదో చూడాలి. See, perpendicular distance, so this is the perpendicular distance. Okay, this is the perpendicular distance, that distance we take d. Perpendicular distance is d. Okay, from here to here, see, this point we take some l. OL is the perpendicular distance. OL is the perpendicular distance. Okay, right. Now see, we can write OL vector, OL bar. OL bar is what? OL bar, how to write OL bar? See, this is the distance, but vector is required. So vector, this is perpendicular to plane, this is also a perpendicular to plane, this is also a perpendicular to plane. So we can write OL bar is d into n cap. N cap is what? Unit vector, normal unit vector, normal perpendicular గా ఉండేటువంటి యూనిట్ వెక్టార్. ఇది పర్పెండిక్యులర్, ఇక్కడ కూడా n cap ఉంటుందండి. ఓకే, ఇది కూడా పర్పెండిక్యులర్, దిస్ ఇస్ ఆల్సో ఏ పర్పెండిక్యులర్. ఓకే, so along this direction, that means perpendicular direction, there is a unit vector, and distance unit into unit vector is that vector OL bar. So we can express OL bar as a d n cap. N cap is a unit vector. N cap is unit perpendicular unit vector or normal unit vector. Normal unit vector to the plane. Plane, right? Okay, dn cap. OL bar is dn cap. Generally we take p. P is a point on the plane. P is a point on the plane. P is a point on the plane with positioner vector r bar. See, this is positioner vector r bar. Okay, this OP, this is, okay, right. Now join this PL bar. Now join this PL bar. Okay, now PL bar, see, P is a point on the plane, L is also a point on the plane. PL bar is perpendicular to OL bar. PL bar is perpendicular to OL bar. Okay, now PL bar is perpendicular to OL bar. Right, okay. So from the diagram, see, from the diagram, PL bar is perpendicular to OL bar. PL bar is perpendicular to OL bar. Okay, andana kada? So right, PL bar is perpendicular to OL bar, right? Now I can write PL bar is also perpendicular to n cap. OL bar ante emi dn cap kada. OL bar ante emi dn cap kada. dn cap perpendicular unte n cap kuda perpendicular e kada. D ante distance, unit vector perpendicular, only unit vector is perpendicular. So PL bar is perpendicular to n cap. Okay, right. So if two vectors are perpendicular, dot product is 0. PL bar dot n cap is 0. What is PL bar? See, r bar minus OL bar. See, r bar minus, see, this position vector is r bar, this vector is dn cap and rasam kada ikkada. Okay na? So position OL bar, positioner vector of this minus this, or LP bar anukunnam. PL bar or LP bar, because for that equation r must be, so first we have to write r. So r LP bar, right, no problem. LP bar cap equal to 0, right. both are perpendicular vectors. So LP bar is position vector of P, R bar minus, okay, position vector of OL. OL is what? Dn cap. Dn cap dot n cap equal to 0. Okay, na? Equal to 0. Right. So R bar minus dn cap dot n cap equal to 0. Okay, right? Dot product. You take dot product of this R bar dot n cap, okay, minus d n cap dot n cap. This is C equal to 0. R bar dot n cap equal to d n cap dot n cap is magnitude of n cap whole square. Magnitude n cap whole square. N cap is a unit vector. That magnitude is 1. Whole square is also 1. So finally R bar dot n cap equal to D. So this is vector equation of a plane in normal form. Vector equation of plane, okay, in normal form, okay, normal form. See, what is D? What is D? D is the distance from horizon to plane. D is the distance from horizon to plane. N cap is a unit vector perpendicular to the plane. N cap is a unit vector perpendicular to the plane, or normal unit vector. N cap is a normal unit vector. Okay, right. Sorry, right. Okay. Write down. Okay. See normal form. Okay, right. So vector normal form lo vector form. See vector equation right, no problem. Vector equation of the plane, okay, of the plane is see in normal form. Okay, here we write normal form. So vector equation of the plane is R bar dot n cap equal to D. R bar dot n cap equal to D. Okay, right. So R bar dot n cap equal to D. Okay, right. So this is normal form. Okay, right. N cap. There is n cap is there. Okay, right. N cap. Listen here, listen please. Alright. So here R bar dot n cap means what? What is n cap? N cap is n bar by magnitude of n bar. Okay. If you divide this equation on the both the sides by magnitude of n bar, we get this. So therefore, okay, right? Okay, right. So right. Next, n cap. Okay, right. So n cap equal to magnitude of n bar by magnitude of n bar. Magnitude of n bar. So we divide both the sides. Okay, right. So this is equal to this. Right. So this n cap equal to this. N cap equal to this. Right. We are writing like this. Then so multiply both sides by n cap. We can get R bar dot. So n cap cancel. N bar equal to, okay, D magnitude of n cap. So this is a number, this is a number. Okay. So implies R bar dot n bar equal to some other constant. We get P. Okay, so r bar dot n bar equal to p. This is also equation of a plane. This is also equation of a plane. Okay, this is also equation of a plane, but this is normal form. From this we get this, right? Okay. Now we have to write vector form. See, Cartesian form. To write the Cartesian form, see, to write the Cartesian form, we take n cap, this r bar equal to xi yj zk. Why we are taking like this? R bar is what? Positional vector of a general point. Positional vector of a general point. Therefore, r bar we can take like this. Next, n cap we can take lx, li cap, m j cap, n k cap. This n bar we can write because these are the direction cosines. Unit vector, because this square plus this square plus this square must be 1, because this is a unit vector. Okay, since it is a unit vector, so magnitude of this must be L square plus M square plus N square. Whenever this L square, this also 1, that is 1. So unit vector, see, unit vector, these are the direction cosines. Unit vector components are direction cosines. This is direction cosine, the direction cosine. So n cap we can write like this, but here n bar we can write a I cap, b j cap, c k cap. Like this we can take n bar. ఎందుకని ఇక్కడ చూడండి, ఇది వెక్టార్, ఇది డైరెక్షన్ రేషియో. దీస్ ఆర్ ది డైరెక్షన్ రేషియోస్. ఏబిసి ఆర్ డైరెక్షన్ రేషియోస్. ఓకే, ఇవి డైరెక్షన్ కొసైన్స్. LMN are direction cosines. So here small a or capital A, whatever it may be, these are the direction ratios of normal vector. Direction ratios of normal vector. వినాలి ఇక్కడ, ఇప్పుడే స్టార్టింగ్ లోనే కన్ఫ్యూజన్ ఉండకూడదు. సో వినండి. So n bar we can write like this, n cap we can write like this. Then substitute these values in the 1 we can get, say, r bar xi yj zk, okay, dot n cap is li mj nk, this equal to d. Here d is the perpendicular distance from horizon to plane. అది గుర్తుపెట్టుకోవాలి ఎప్పుడు ఇక్కడ n cap ఉన్నప్పుడు. సో n cap బదులే మనం ఇలా అన్ని రాసేసాం. సో దెన్ ఫైనలీ దిస్ ఈక్వేషన్ ఈజ్ lx plus my plus nz equal to d. This is Cartesian form of the plane. Cartesian form. This is Cartesian equation of the plane. Okay, Cartesian equation. This is vector equation. Okay, this is vector equation. This is Cartesian equation. Cartesian equation for this form we can write like this. Here, see, r bar equal to x. So xi yj zk dot n bar nila rasam ai bj ck equal to p. So ax plus by. So this is one vector, this is another vector. Okay, ax by cz equal to p. This is also a, okay, this is general equation, we can say this. So this is also equation of a plane. This is also equation of a plane. This is also equation of a plane. Okay, this is vector form. Its related Cartesian form is this. Okay.
Ax plus by.
Right. So by. Okay, by. Right. R bar dot n cap equal to d is the equation of a plane in normal form. Okay, that is vector equation of a plane in normal form. This lx plus my plus nz equal to d is the Cartesian equation of a plane in normal form. Okay na? Normal form ante emi? Normal unit vector and distance from horizontal plane when both are given. So this is the equation, vector equation. This is the Cartesian equation. ఓకే, ఇక్కడ ఎన్ క్యాప్ ఉండబట్టే ఇక్కడ ఎల్ ఎమ్ ఎన్ వచ్చినాయి. ఆ ఎన్ క్యాప్ లేకుండా ఇక్కడ ఇలా ఉండేది అనుకో, ఆర్ బార్ డాట్ ఎన్ బార్, ఇదిగో ఇక్కడ వేసాం కదా, ఆర్ బార్ డాట్ ఎన్ బార్ ఈక్వల్ టు పి అయితే పి ఈజ్ నాట్ పర్పెండిక్యులర్ డిస్టెన్స్ ఫ్రమ్ ఒరిజిన్ టు ప్లేన్ కాదు. ఎప్పుడైతే యూనిట్ వెక్టార్ ఉంటుందో అప్పుడు వచ్చేటువంటి ఇక్కడ కాన్స్టెంటే, దట్ ఈస్ ది డిస్టెన్స్ ఫ్రమ్ ఒరిజిన్ టు ప్లేన్. ఇక్కడ యూనిట్ వెక్టార్ ఉండాలి. ఇక్కడ యూనిట్ వెక్టార్ ఉన్నప్పుడే ఇక్కడ వచ్చేటువంటి నంబరు, ఏ నంబర్ వస్తే ఆ నంబరు, దట్ ఈస్ ద పర్పెండిక్యులర్ డిస్టెన్స్ ఫ్రమ్ ఒరిజిన్ టు ప్లేన్. ఓకే, ఇక్కడ కూడా ఒకవేళ కార్టీషియన్ ఈక్వేషన్ ఎల్ఎక్స్ ఎంవై ఎన్జెడ్, ఎల్ఎక్స్ ఎల్ఎంఎన్ ఎల్ఎంఎన్ ఇవి వచ్చేసి ఎల్ఎంఎన్ అంటే మీ డైరెక్షన్ కొసైన్స్ ఆఫ్ ఏ యూనిట్ వెక్టార్. యూనిట్ వెక్టార్ యొక్క డైరెక్షన్ కొసైన్స్ ఉన్నప్పుడే ఇక్కడ వచ్చేటువంటి నంబరు ఏమవుతుంది, పర్పెండిక్యులర్ డిస్టెన్స్ ఫ్రమ్ ఒరిజిన్ టు ప్లేన్. అంతేగాని ఇక్కడ వచ్చేటువంటి చూడండి, ఇక్కడ వచ్చేటువంటి నంబరు ఇది పర్పెండిక్యులర్ డిస్టెన్స్ కాదు, ఒక నంబర్ మాత్రమే, అది ఒక నంబరే. సరే, ఇక్కడ చూడండి ఏబిసి అంటే ఏంటి, ఏబిసి ఆర్ డైరెక్షన్ రేషియోస్ ఆఫ్ నార్మల్. ఇక్కడ రాసుకోండి, ఏబిసి ఆర్ డైరెక్షన్ రేషియోస్ ఆఫ్ నార్మల్. అదే ఇక్కడ ఎల్ఎంఎన్ వచ్చేసి ఎల్ఎంఎన్ డైరెక్షన్ కొసైన్స్ ఆఫ్ నార్మల్ యూనిట్ వెక్టార్. ఓకే, సో ఈ డిఫరెన్స్ అన్ని మీరు ఐడెంటిఫై చేయాలి. రైట్, ఓకే, రైట్. సో this can be changed like this. This equation can be changed like this. ఎలా చేనండి జాగ్రత్తగా. See, this is normal form. This can be written as r bar dot n bar equal to p. This can be changed like this. How? By dividing magnitude of n bar. దీన్ని magnitude of n bar తో డివైడ్ చేస్తే ఇలా అయిపోతుంది కదా. ఇక్కడ చూడండి, దీన్ని magnitude of n bar తో డివైడ్ చేస్తే ఇలా అయిపోతుంది. ఎలా అయిపోతుంది ఇక్కడ చూడండి, ఆర్ బార్ డాట్ ఎన్ బార్ బై మ్యాగ్నిట్యూడ్ ఆఫ్ ఎన్ బార్. ఇక్కడ డివైడ్ చేశావు కాబట్టి ఇక్కడ కూడా డివైడ్ చేయి. ఓకే, ఇప్పుడు ఇక్కడ వచ్చేటువంటి ఈ డిస్టెన్స్ ఏమవుతుందంటే డి అయిపోతుంది. ఇది ఎన్ క్యాప్ అవుతుంది కాబట్టి ఇది డి అవుతుంది. డి అంటే ఏమి, పర్పెండిక్యులర్ డిస్టెన్స్ ఫ్రమ్ ఒరిజిన్. అంటే ఇక్కడ నార్మల్ యూనిట్ వెక్టార్ లేకపోతే ఇప్పుడు పర్పెండిక్యులర్ డిస్టెన్స్ ఫ్రమ్ ఒరిజిన్ టు ప్లేన్ కనుక్కోమన్నాడు అనుకో, ఇది ఏదో తెలియదు మనకి. అప్పుడు ఏం చేయాలి, ఇక్కడ నార్మల్ యూనిట్ వెక్టార్ని తీసుకురావాలి. సో నార్మల్ యూనిట్ వెక్టార్ని తీసుకురావాలంటే ఈ వెక్టార్ యొక్క మ్యాగ్నిట్యూడ్తో డివైడ్ చేయాలి. అప్పుడు ఇలా మారిపోద్ది. ఇలా మారిపోతే ఇక్కడ వచ్చేటువంటి కాన్స్టెంట్ పర్పెండిక్యులర్ డిస్టెన్స్ అవుతుంది. అది రైట్. ఇక్కడ కూడా చూడండి, దీన్ని ఈ ఈక్వేషన్ లాగా మార్చొచ్చు. ఎలా మార్చొచ్చు అంటే ఇక్కడ చూడండి, ఏబిసి డైరెక్షన్ రేషియోస్ కదా, అక్కడ డైరెక్షన్ కొసైన్స్ రాయాలి. ఎలా రాస్తాము, ఏ బై రూట్ ఆఫ్ ఏ స్క్వేర్ ప్లస్ బి స్క్వేర్ ప్లస్ సి స్క్వేర్తో చేసామనుకో. సో అదేవిధంగా బి బై ఈ ఎక్స్ అని పెట్టాలి, బి బై ఓకే, ఇది కూడా ఏ స్క్వేర్ ప్లస్ బి స్క్వేర్ ప్లస్ సి స్క్వేర్ వై, సి బై ఏ స్క్వేర్ ప్లస్ బి స్క్వేర్ ప్లస్ సి స్క్వేర్ జెడ్, పి బై ఇక్కడ కూడా డివైడ్ చేయాలి కదా, రెండు వైపులా డివైడ్ చేయాలి చేస్తే. సో ఏ స్క్వేర్ ప్లస్ బి స్క్వేర్ ప్లస్ సి స్క్వేర్. ఓకే, ఇప్పుడు ఇదేమవుతుంది, డి అయిపోతుంది. ఎందుకంటే ఇదంతా ఎల్ కదా, ఎల్ఎక్స్ ప్లస్ ఎంవై ప్లస్ ఎంజెడ్ అయింది కాబట్టి దిస్ ఈజ్ డి, దిస్ టోటల్ వాల్యూ ఈజ్ డి. దీన్ని ఇలా మార్చొచ్చు. అర్థమైందా? ఓకే, రైట్. సో రైట్. ఓకే, ఇంతసేపు చాలు. This is enough, right? Okay, write down. Okay, example. First example. Find vector equation of the plane which is at a distance of 6 by root of 29. Okay, 29 from the horizon, and its normal vector from the horizon is normal vector 2i minus 3j 4k. Okay, it is not a normal unit vector, it is only normal vector. Normal vector, right? Okay, see what is given here. Vector equation we have to find. So distance of 6 by root of 29 from the horizon. Okay, this is d equal to 6 by root of 29, and then this is normal vector n bar is not a unit vector. Normal vector is given 2i minus 3j 4k. Now you find n cap. Find n cap. So how to find? Right, very good. So magnitude you divide. So 2 square plus 3 square plus 4 square. How much? 16 plus 9, 25, 29. So normal vector is 2 by root of 29. Okay, I 3 by root of 29 j 4 by root of 29 k. This is n cap. Okay, now write, see, vector equation is r bar dot n cap equal to d. So r bar dot n cap is 2 by root of 29. Okay, or otherwise we can take 20 root of 29 2i minus 3j 4k, like this, is equal to d equal already given. D means what? Perpendicular distance. Whenever we are writing into n cap, this must be perpendicular distance from horizon to plane. So that is given. So which is distance from horizon, perpendicular distance, right? 6 by root of 29. Distance is perpendicular distance only. Distance is always perpendicular. So right. So then it implies this equation is r bar. This 29 we can cancel. Okay. R bar dot 2i minus 3j 4k equal to 6. So right. This is the vector equation. That is the vector equation. Okay, right. So this is the vector equation. Right. Next problem is right. Find the direction cosines find the direction cosines of a unit vector perpendicular to the plane r bar dot 6i minus 3j minus 2k plus 1 equal to 0. Okay, right. See, find the direction cosines of unit vector perpendicular. This is normal unit vector. Normal unit vector direction cosines kavali. This is the plane equation. See, this is 6i minus 3j 2k equal to minus 1. This is equation of a plane. This is vector equation, okay, right? Vector equation of plane, right? See, in this, see, first we have to verify whether this is a n cap or not, n cap or n bar. First we have to verify. So if it is n cap, this should not be negative. If it is n cap, ఇది n cap గాని అయి ఉంటే ఇది నెగటివ్ ఉండకూడదు, ఎందుకంటే ఇది పర్పెండిక్యులర్ డిస్టెన్స్ కదా. ఓకే, ఇది n cap కాదు, అవునో కాదో వెరిఫై చేయాలి. 6 స్క్వేర్ 3 స్క్వేర్ ప్లస్ 2 స్క్వేర్ is not equal to 1. Okay, therefore it is not a unit vector. Now you make it unit vector. Unit vector గా చేయి దీన్ని. ఏం చేద్దాం? r bar dot so 6i 3j 2k by magnitude of 6 square 3 square 2 square. ఇటువైపు కూడా చేయాలి కదా, సేమ్ 6 స్క్వేర్ 3 స్క్వేర్ 2 స్క్వేర్ ఎంత వస్తుంది? హౌ మచ్? 6 స్క్వేర్ 36, 9 on 4 and 49, 7, right? So 6i 3j 2k by 7 minus 1 by 7. See, whenever this is n cap, this should not be negative. So therefore multiply both sides by minus. Huh? Okay, so to change this minus, multiply minus 6i plus 3j plus 2k by 7. Now it is n cap. See, this is in the form of r bar dot n cap. This equal to d. This equal to d. 1 by 7 is d now. D is the perpendicular distance from horizon to plane. So that is asked. Direction cosines. Okay, okay. Direction cosines. See, direction cosines of unit vector. Normal unit vector. Unit vector normal. Normal unit vector are minus 6 by 7, 3 by 7, 2 by 7, right? Okay, right. Right, okay. Next we take one more example, right? Find distance. Find distance of the plane 2x minus 3y 4z minus 6 equal to 0 from the horizon. Okay, right? From the horizon. Find the distance of plane from the horizon. See, equation of plane is this: 2x minus 3y 4z, okay, equal to 6. This is the equation of plane. Okay, see, distance from horizon to plane. Whenever to find the distance from horizon to plane, normal direction, normal should be unit vector. So that means these must be direction cosines. ఇంతేనా? ఇక్కడ చూడండి, ఇందాక ఏం రాశానంటే నేను అక్కడ ax ప్లస్ by ప్లస్ cz ఈక్వల్ టు d అని రాశాను. అక్కడ ఏదో సమ్ d, ఆ dకి dకి సంబంధం లేదు, ఇంకోటి ఏదైనా రాద్దాం, కావాలంటే p అని రాద్దాం. ఓకేనా? ఇలా ఉన్నప్పుడు ఇవి డైరెక్షన్ రేషియోస్, ఇవి వీటిని డైరెక్షన్ కొసైన్ చేస్తే ఇది పి అప్పుడు ఇది డి అయిపోతుంది. అర్థమైందా? సో ఇది 2 square 3 square 4 square is not equal to 1. Okay, therefore these are not direction cosines. అర్థమైపోయింది. Right, now divide this by 2x minus 3y 4z by root of 2 square plus 3 square plus 4 square. In the same way divide this side also. 2 square plus 3 square plus 4 square. This is root of 29. 4z by root of 29. This 6 by root of 29. Okay. So what we have to find? See here. Okay. I will write it one more step. This is x. 3 by root of 29. Y plus 4 by root of 29 z equal to 6 by root of 29. See here, this square plus this square equal to 1. Okay, right. So in that case this is equal to distance, d equal to distance, right. So perpendicular distance from horizon to plane, perpendicular distance or distance from horizon to plane, d equal to 6 by root of 29 units. That is perpendicular distance. Okay, right. Oh, no problem. Right, only one form is completed in this class. Right, no problem. Okay, right. One more example. Find the coordinates of the foot of the perpendicular foot of the perpendicular drawn from the horizon to the plane. 2x minus 3y plus 4z minus 6 equal to 0. Right. Okay. So okay, right. See. So x, y, z. Okay. There is a plane here. This is a plane. Okay. Right. So from horizon to, see, foot of the perpendicular drawn from horizon to plane. So we have to draw the perpendicular. Okay. So this is the perpendicular. Okay, now this perpendicular foot is this foot of the perpendicular drawn from horizon to plane. So this is the top, this is the foot. Okay, okay, right. So this point we have to find. So that point is, we write some p x1 y1 z1. This we have to find, foot of the perpendicular x1 y1 z1. Okay, see this equation, what it gives: 2x minus 3y 4z equal to 6. This is equation of plane. Is the equation of plane. Okay. See here. What is 2 minus 3 4? 2 minus 3 4. What are these? These are the direction ratios of normal to plane. Normal direction, normal to plane. Okay. See here, this is the distance. OP is the distance from horizontal plane. Distance means perpendicular. Right. So this is perpendicular. This is also a perpendicular. But here normal direction is, so this is normal, right? This is also a perpendicular to the plane. Direction ratios of this is 2, -3, 4. Two lines are parallel. These two lines are parallel. Direction ratios are same or proportional. So we can take direction ratio of these. Okay, direction ratio of this OP direction ratio తీసుకోవచ్చు మనం. వినాలి. So now we write equation of OP line. OP లైన్ యొక్క ఈక్వేషన్ రాస్తున్నాం మనం ఇక్కడ. ఆ ఈక్వేషన్ ఎలా ఉందంటే, దిస్ ఈజ్ పాసింగ్ త్రూ దిస్ పాయింట్ x minus x1 by 2, y minus y1, okay, by -3, z minus z1 by 4 equal to lambda. This is what equation of a line passing through single point parallel to another vector. Okay, so these direction ratios are equal to direction ratios of this. Okay, right, okay, na, right. From this, okay, right. So this x1 we have to find, right. So equation of the plane, right, okay, or you can take direction ratios, right. So we will go this side. This is somewhat to take longer step, right, okay. Now we find the direction ratios. We make it equal. See, direction ratios of OP. This is easy process. Direction ratios of OP we can write. So R. So this is 0, 0, 0. Okay. This is x1, y1, z1. So difference between these x coordinate, y coordinate, z coordinate are direction ratios. So x1, y1, z1 direction ratio. These directions both are parallel. So these we can take, both are proportional. So see, direction ratios of OP bar. Direction ratios of normal are 2, -3, 4. So see, these two are parallel. OP is parallel to normal. So therefore, so these are proportional. x1 by 2, y1 by -3, z1 by 4 equal to lambda. The proportional value is lambda. From this, x1 equal to 2 lambda, y1 equal to -3 lambda, z1 equal to 4 lambda. Right, okay. Right. Now x1, y1, z1 is a point on the plane. x1, y1, z1 is a point on the plane. Okay, substitute x1, y1, z1 in the plane lo substitute cheyali. So to get lambda value. Okay, right. So 2x, in the place of x, 2 lambda. Okay, in place of x substitute x1, that is 2 lambda minus 3 into -3 lambda plus 4 into 4 lambda. Okay, this equal to 6. See here, 4 lambda plus 9 lambda plus 16 lambda equal to 6. How much? 16, 25, 29 lambda. 29 lambda equal to 6. Lambda equal to 6 by 29. Okay, 6 by 29. And finally we have to find x1, y1, z1 value. So x1 value is 2 times of lambda. So we can write finally x1 y1 z1, x1 equal to 2 into 6 12 by 29, y1 equal to minus 3 18 by 29. Okay, z1 equal to 4 24 by 29. So this is foot of the perpendicular, right? Okay.